If you've ever written software, you know the feeling. Your code works perfectly until it doesn't. A bug pops up and crashes the whole thing. Well, learning to handle those inevitable errors, those exceptions, that's really what separates good code from great, professional, and truly solid software.
We have all been there. I mean, staring at a stack trace that just seems to go nowhere, hunting down some phantom bug that only shows up after the app has been running for hours. It's enough to make you want to pull your hair out.
And then you've got those other bugs, the ones where the error message basically hands you the answer on a silver platter. You spot the typo, you fix it, and you're done. Less than a minute.
So what's the difference between that 1-minute fix and a 3-day nightmare? It's not luck, and it's definitely not magic. It all comes down to having a deliberate strategy for how your code deals with things when they go wrong, and that's exactly what we're going to break down today.
Okay, so first things first, let's get on the same page. What is an exception, really?
The easiest way to think about it is like a fire alarm for your code. When something totally unexpected happens, maybe a file it needs is missing or the network connection just drops, an exception gets thrown. It stops everything and basically yells, hey, we've got a serious problem over here that someone needs to deal with right now.
So to deal with that alarm, pretty much every modern language gives us a standard set of tools. You can think of this as your code's safety net, designed to catch these problems before they take down the whole show.
You know, this whole process is a lot like a fire safety plan. The try block, that's you doing your normal day-to-day work. The catch block is your fire extinguisher. It's built to handle a very specific kind of problem. And the finally block, that's the cleanup crew. No matter what happened, fire or no fire, they come in at the end to make sure essential things like closing a file or a database connection get done. But here's where it gets really interesting. Just because you have that safety net doesn't mean you should use it for every single little thing that could go wrong. Knowing when to catch an exception is just as important as knowing how to do it. I mean, just look at Microsoft's own guidance on this. For things that are pretty common and predictable, like, say, checking if a database connection is already closed, a simple if statement is way better. It's faster, it's cleaner. You should save the whole try-catch setup for things that are truly exceptional, not for your everyday checks.
Okay, this next idea, this is a complete game changer. It's a philosophy that kind of flips the whole idea of making your code robust on its head. It's called failing fast.
I absolutely love this quote. It feels so wrong at first, but it's incredibly powerful. The idea is, instead of trying to silently work around a problem, you want the failure to be as loud, as obvious, and as immediate as possible. The difference between these two is everything. A fail-slow system is an absolute nightmare to debug. An error happens, but the program just kind of limps along, maybe corrupting data as it goes, until it finally crashes somewhere totally unrelated. But a fail-fast system? It stops dead in its tracks the second something is wrong, leaving a perfect, crystal-clear trail right back to the cause. Let's make this super practical. In the fail-slow scenario, maybe a missing config value causes weird performance issues that take you days to track down. But look at the fail-fast case. The program immediately throws an exception with a super clear message. The bug is obvious, and you fix it in seconds. That right there is the power of this idea. So, once you've embraced failing fast, you can start to really polish your technique. Let's look at a couple of more advanced practices that'll seriously level up your code. Okay, here's a pro tip. When you catch an exception but then decide you can't actually handle it there, you need to rethrow it. But how you do it matters a ton. If you use throw E, you actually reset the stack trace. You're basically erasing the evidence of where the problem really started. But if you just use a simple throw with nothing after it, you preserve all that crucial information. You're leaving all the clues for the next person who has to debug this. Another really powerful tool is something called exception chaining. Imagine your data layer throws a super generic SQL exception. That's not really helpful to the person using your app, right? So with chaining, you can catch that generic error and then wrap it in a new, much more descriptive one, like a could not load user profile exception. You get to add helpful context, telling a better story about what went wrong, all without losing the original nerdy details. All right, let's talk about one of the most critical parts of handling errors: leaving things in a good, clean state. Here's the classic example. You're writing code for a bank transfer. You withdraw money from account A, but then the deposit into account B fails. What happens to that money? Is it just gone? A really robust system uses that catch block to perform a rollback. If that deposit fails, the code in the catch block immediately reverses the withdrawal.
This makes sure that the system never ends up in some weird, corrupt state where money has just vanished into thin air. The goal is to leave no trace that the failed operation ever even started.
So, what's the big picture here? What does all this really mean? Well, it's about shifting your mindset. You're not just trying to stop your app from crashing, you're proactively building software that is just plain easier to debug and maintain.
So let's wrap it up. Your goal is to be proactive, not just reactive. You want to be strategic about when and where you use exceptions. Embrace that fail-fast philosophy, make your errors loud and clear. And finally, always clean up after yourself. Restore the state so your application stays stable, even when things go sideways.
Look, this isn't just theory. I want you to think about the code you're working on right now. Can you find one place, just one, where you could replace a silent failure, like returning a null, with a loud, clear exception? Making one tiny change like that this week could literally save you or one of your teammates hours and hours of debugging down the road.